Hello and welcome everyone to the second part of our topic review. Topic review 2. This one's dedicated to finding angles. All those different trigonometry questions we've done where it was the angle that we were finding. Alright, let's just get straight into it. There's 3 examples. Just to refresh your memory of the different skills, there's nothing new here. This is all stuff that we've learnt in previous lessons. Hopefully you guys have gone through those lessons already. If you're watching this one, it means you probably already have. And a couple questions for you to practice at the end. You will need book, pen, calculator, you know the deal. Once you've got your maths equipment, you can continue on with this video and let's begin. All right, first example, and again, just like all our other lessons, the examples we will be getting into our books. Pause the video whenever you need to get it written down and resume whenever you're ready for it. All right, example 1, we're going to find theta to the nearest degree. What is theta? Just a random pronumeral. There's that angle down the bottom there. We're trying to find the size of it to the nearest degree, right? Almost certainly it'll be like in between two particular angles. We're just going to be, well, which one is it closest to? Okay, so how do we do it? First things first, let's label the sides. We have the hypotenuse and we have the adjacent. We can see the blank side we do not care about. Just like finding side lengths, there's always 2 sides we're dealing with here. Now that we've done part 1 and we've labeled the 2 sides that are of interest, we then look at SOHCAHTOA and that'll tell us which question this one is. It is a cos question. A and H mean cos. So we got to write out this trig ratio. Cos, remember, always put in the angle with the trig. In this case, we don't know the angle. We're just calling it theta, but it could mean x, y, a, I don't know, whatever the pronumeral is. So cos of the angle is equal to a and then h, adjacent, and then hypotenuse. All right, we've done now the second step. We've written out that trig ratio. Remember, we're finding angles. To get the theta by itself, we need to get rid of the cos. I should say move cos to the other side or do the opposite of cos, and it becomes this cos to the minus 1. All right, so when doing that, we bring the cos across, it becomes a cos to the minus 1, and then we're just left with typing this into our calculator. If you've forgotten how to get that cos to the minus 1, in your calculator, you press the shift button and then press cos. That shift, you'll notice, is in yellow writing, and that activates all the yellow parts of the buttons, which is why when you look above the cos in little yellow writing, it has that cos to the negative 1, or what we actually properly call inverse cos. So shift cos gets that up, and you type in the 17 over 21, you press equals, and again, we're just rounding it to the nearest degree. And I believe it's 36 degrees is what you get. All right, first example. Once you've got that copied into your book, let's move on to the second. All right, example 2. Yet again, we're going to find the size of this angle, but this time it's to the nearest minute. Makes no difference for us. The steps are all the same, really. We just have to press one extra button at the end. I'm already sweating. There's a blank side, which I'm ignoring. That was the hypotenuse, but hey, I'm not interested in that. The other 2 sides, one is the opposite. Clearly you can see 10 is opposite. And 15 is next to the angle. That's how adjacent. SOHCAHTOA. Okay, so if you're not familiar yet because you haven't done enough questions, O and A does belong to 10. But, you know, SOHCAHTOA will tell you anyway. I guess that's why it's so useful. So O and A makes a 10 question. So 10 of the angle is equal to opposite over adjacent. We've written out our trig ratio. And now we're trying to find the angle. It means we've got to get rid of this 10. We take that 10 to the other side where it becomes the opposite of 10. Or in other words, inverse 10. And again, we're just left with typing this into our calculator. So this time you press shift 10, 10 over 15, press equals, and you will get an answer which is like, like 33 point something. It's some sort of long decimal, right? But we've been asked to round this to the nearest minute. So we have this extra step where to convert it from just a degree with a decimal into degrees, minutes, and seconds, you just press the degrees, minutes, seconds button. If you happen to have a really old calculator, the button actually, it's called DMS, which you can imagine stands for degrees, minutes, and seconds. Anyway, you press that button, it'll convert it for you. I'll get rid of this. And so you end up with 33 degrees, and I believe it's 41 minutes is what you end up getting. And for those that are curious, you know, hey, here's a protractor, 0 degrees, 90. You know, the 33 degrees is about here. The actual angle we will find in this theta is just a fraction bit above 33. It's 33 degrees and an extra 41 of those minutes. So it actually is closer to 34 degrees, but anyway. That's our answer, 33 degrees and 41 minutes. I'll get rid of this because that's just going to confuse things. And we'll move on. Once you got this into your books, we'll move on to the final example. All right, so what is example 3? All right, it's an angle of elevation question. I can see that right here. So with trigonometry, remember you want a triangle, right? And you're either finding the side length or an angle. Ultimately, that's all it is. It's a triangle where you've got to find one of the angles or one of the sides. With angle of elevation questions, remember, there is no triangle. You need to create your own triangle. So let's have a little read. A plane takes off and is 400 meters above the ground after flying 3 kilometers through the air. That right there, let's just draw up what's been written. Okay, here's the ground. A plane takes off. Here it is. It's taking off in this direction here. There it goes. Here is like plane. You have to use your imagination a little bit. That doesn't particularly look like... Anyway, whatever. And now it actually looks more like a bird. All right, so we've got this plane that's taken off, and we've been told it is 400 meters above the ground after it's flown 3 kilometers through the air. So it's flown 3 kilometers through the air. I've got meters and kilometers. You know, we need some sort of common unit here. Yeah, hey, Angie. So, and that... Yes, yep, I'll get you some more. Just give me a quick sec. All right, so in this particular case here, this is our triangle. We've got 3,000 meters. That's 400 meters. We want to find the angle of elevation, which is the angle above the horizontal. This is our triangle. And now that we have the triangle, we can then just solve the question just like normal. You know, in this particular case, what do we have? We have the hypotenuse. We have the opposite. The adjacent side is blank. We don't care about that. This is an O and H question. So it's a sign question. Remember, SOHCAHTOA, which one is O and H? It's the sign that has the O and the H. So let's write out our trig ratio. Sine theta is equal to opposite over hypotenuse. We're trying to find theta. So we need to move the sine across. When we move the sine to the other side, it becomes inverse sine. Type it in your calculator, press equals. We haven't been told what to round to, so I'm going to round to like 1 degree here for sure. I mean the nearest degree. So typing that in, pressing equals, 8 degrees. That plane was taking off with an angle of elevation of approximately 8 degrees. For those that want a bit more accurate, it was like closer to 7.5, but whatevs. Third example, make sure you got that in your books. And now is the time when you get to have a quick practice. There's 2 questions for you guys to do yourselves. I want you to find the size of the angle theta. So pause the video, have a go at answering these 2 questions yourselves. Once you have answers, unpause the video and I'll put the answers up. Okay, so hopefully everyone's had a chance to have a go. The first one, typing it in. We weren't told what to round to. You could have went to the nearest minute if you wanted to be more accurate. I just went to the nearest degree. The first one, theta was approximately 60 degrees. And for the second one, theta was approximately 40 degrees in size. All right, hopefully this has helped. Definitely best of luck when you have a go at the topic test, which is on Canvas. But yeah, if you have any questions, you know what to do. Either leave the questions here on YouTube or back through Canvas, and I'll do the best I can. All right, I'll see you guys for the next one. Bye.